Our next speaker is Francois Grey. And Francois works in an IT department. And he does outreach and public relations for an IT department. You might wonder, why does an IT department need somebody doing outreach and publications? Well, if this IT department is at CERN, where the web was created, and where they're building grid technology to handle all the data pouring out of the Large Hadron Collider, you get a lot of attention at that place. And that IT department is the focus of a lot of media attention and public opinion and world opinion. And Francois is heading up their outreach and public relations. He's got a background in physics, and he's going to talk to us today about some exciting things that his team is doing based at CERN throughout the world. Please help me welcome Francois Grey.
Thanks. I'd like to conclude this session on the web and enterprises by focusing on one particular form of human enterprise called science. And I'd like to tell you about a particular way in which the web is changing the scientific enterprise. You could call it a trend, or perhaps a paradigm shift, maybe, if you're bold, a revolution. What I'm referring to is the way that the web is enabling millions of ordinary citizens with no professional scientific credentials to contribute in a meaningful and valuable way to science. And the take-home message of this talk is that volunteer computing, which is a trend which became popular nearly a decade ago with SETI at Home and projects like that, is evolving into something you could call volunteer thinking, which is an altogether more profound way of engaging the public in science and engaging scientists with the public. But before I get to the core of my talk, I'd like to point out that the web is itself a spin-off of the scientific enterprise. Nearly 2 decades ago, Tim Berners-Lee and his colleagues developed the web at the European Particle Physics Laboratory, CERN, just down the road. So I thought I should mention briefly what CERN's up to these days, because the big event of 2008 may not be the Beijing Olympics, it may not be the US presidential elections, and it may not, with all due respect to our first speaker, be the marriage of Carla Bruni and Nicolas Sarkozy. The really big story in 2008, when we look back 20 years from now, may be that CERN switched on the largest physics experiment on the planet, the Large Hadron Collider, or LHC. The LHC is housed in a tunnel 27 kilometers in circumference and roughly 100 meters underground. This particle accelerator will smash 2 beams of protons together at unprecedented energies, creating, in a microscopic space and for a fleeting instant of time, a state of matter similar to our universe, just a fraction of a second after the Big Bang. And this will reveal, we hope, exotic new particles like the Higgs boson, and perhaps even mini black holes. Well, the LHC will also be the single biggest producer of scientific data on the planet. 4 cathedral-sized underground particle detectors, each one containing over 100 million electronic sensors, will record digital images of the proton collisions at 40 million images per second. This will add up to a total of about 15 million gigabytes of data a year. That's a stack of DVDs the size of Mont Blanc. Put it another way, it's about 1% of all the data created by all the humans on this planet each year, be it digital or non-digital. So, to analyze this data in search of new particles, a dedicated processing capacity is required, equivalent to about 100,000 of today's fastest processors. And to achieve this, CERN and hundreds of academic institutions around the world have collaborated to establish a grid, the LHC computing grid. So from Chicago to Tokyo, from Vancouver to Taipei, data centers like this one here at CERN are going to store and analyze the data from the LHC using a dedicated backbone, 10 gigabits per second, to ship data around the planet at gigabytes per second. Now, compared to this, volunteer computing, which is what I'm going to talk about in the rest of this, is a sort of poor man's grid, where any old PC on the internet can simply connect to a server in a university, download some scientific data, process it, and upload the results. Volunteer computing made the headlines with SETI at Home, which analyzes data from a radio telescope in search of signals from extraterrestrial beings in other solar systems. Bad news is, ET has not phoned home yet, but the project really captured the public imagination. Millions of people have downloaded SETI at Home, and at any one time, more than 500,000 processors are crunching data for this project. Not bad for a poor man's grid. But perhaps the most exciting thing about SETI at Home is that it has spawned a host of other volunteer computing projects like Fight Cancer at Home or ClimatePrediction.net. In total, there are now well over 50 of these projects. One outstanding example is this project Folding at Home, which does protein folding simulations to study diseases like Alzheimer's. Sony is preloading the project on PlayStation 3s, and as a result, because the cell processor is so powerful, with about 50,000 PS3s contributing to this project, it passed the petaflop barrier. That means 1,000,000 billion floating point operations per second. That's something even the fastest supercomputers in this world cannot match. Not bad for a poor man's grid. So let's just see a show of hands here. Who in the audience has ever volunteered for SETI at Home or any of these others? Okay, cool, you rock. Right? Right? Well, a few years ago, together with a colleague of mine, Ben Siegel, who's in the audience here, we set up a volunteer computing project at CERN for the LHC called LHC at Home. Not very original. Well, unfortunately, the enormous quantities of data coming from the LHC detectors are simply too overwhelming to ever handle with a volunteer computing network. But we discovered that there were accelerator physicists at CERN who simulate how the protons circulate around the LHC, and they needed some extra computing power to do these simulations. And their program was well suited to volunteer computing. So with the help of a host of summer students, summer students are the power behind all technological progress, we ported their program to BOINC. BOINC is an open source platform for volunteer computing, which was created by David Anderson at Berkeley. He's the guy behind SETI at Home as well. So over the last few years, LHC at Home has provided the accelerator physicists with a processing power equivalent to a cluster of more than 1,000 computers, which they never could have afforded otherwise. So for them, volunteer computing represented a huge free resource. Did I say free? Well, not quite. The success of volunteer computing projects depends on good communication with the volunteers. And this requires some effort. You have to make an eye-catching screensaver, and you have to keep volunteers informed about the project via BOINC's message board system. Actually, the BOINC message boards are social networking with a scientific purpose. People share cool stuff they found out about the LHC and physics in general. Just like other social networks, volunteers also make friends, fall in love, have arguments, and leave in disgust, not necessarily in that order. Another key incentive for many volunteers is credit. BOINC has a credit system, which I hasten to add has no monetary value whatsoever. And volunteers get credit in proportion to how much processing they do. Many volunteers are very competitive about their credit. There are competitions between individuals and teams, and some people are so competitive they actually cheat and try to fake their credit. That's amazing. Well, one thing we discovered many things from working with this kind of environment, but one thing we discovered was that if for some reason there was a break in the simulation work we were doing with LHC at Home, so there was no data available for the volunteers to process, well, pretty soon they would kick up a big fuss on the message boards. Basically, they'd be screaming for more data to process. This was a big surprise to us. Who has ever heard of a data center that complains if you do not send it more work? Right? It was really the world upside down. However, we discovered that as long as we explained to the volunteers why we were stopping and when we might start up again, they were very forgiving. So the realization for us as scientists was that the volunteers are really partners in the scientific project and have to be treated with due respect. So now I'd like to talk about the new trend, volunteer thinking. So the name might conjure up some freaky image of plugging people's brains into the internet like the Matrix. But in fact, the spirit of volunteer computing, the spirit of volunteer thinking is about enabling ordinary people to become hands-on scientists. So, of course, such citizen science is nothing new. Amateur astronomers, amateur archaeologists have been making important contributions to science for generations. But the combination of the web, of high-speed networks, and the relentless progress of Moore's law is vastly increasing the potential for people to contribute to science on a global scale. I like to call this phenomenon citizen cyberscience. So, a nice example of this new trend is a project called Galaxy Zoo. The project has farmed out images of 1 million different galaxies taken by the Sloan Digital Sky Survey. In a matter of months, over 100,000 volunteers used a simple web interface you see here to classify whether each galaxy was spiral or elliptical. Now, a key concept of volunteer computing is validation, sending the same task to many computers or many people and then comparing the results. If they generally agree, then you can have some confidence in the result. In fact, the Galaxy Zoo team discovered that the volunteer thinkers were statistically more reliable than if a professional astronomer had classified the images. One reason for this is that if you asked a professional to do this, after about a few thousand galaxies, he'd get bored and he'd start to make mistakes. But for the volunteers, their work on the project is an exciting change from their everyday lives, which many take very seriously. And some volunteers spotted new, strange galaxies that were neither spiral nor elliptical, and this has inspired astronomers to go back and study these in more detail. So while studying galaxies might seem sexy, what scientists are discovering about volunteer thinking is that there are volunteer thinkers happy to do far more esoteric tasks. Herbaria at Home is a project that aims to digitize the wealth of handwritten 19th century data on plants archived in dusty British herbaria and museums. Thousands of volunteers have already digitized tens of thousands of these data sheets. The scientific point here is that many of the plants in these collections are already extinct, and this is a last link to flora of another era. The technological challenge of the project, though, is that you have to ship very high-resolution images, typically tens of megabytes, in order to decipher the writing. 10 years ago, maybe even 5 years ago, that would have made the project impossible. So volunteer thinking is emerging fast because the web is developing so fast. Now, before I go on, I'd like to distinguish this sort of citizen cyber science from two other very significant trends on the web. One is online games that get people to solve useful problems. An example that you may have heard of is the ESP game, which gets you to index images on the web by turning a boring task into a fun game. Getting people to solve problems for fun is cool, but it's not citizen cyber science. Then there is the approach where you get people to solve problems for money. This has been dubbed crowdsourcing by Wired magazine. A prominent example of this is Amazon's Mechanical Turk project, which farms out small tasks for very small amounts of money. This is also cool, but it's not citizen cyber science, because citizen cyber science is about getting people interested in science and allowing them to contribute personally, passionately, to the scientific enterprise. So, I'd like to wind up my talk with a few words about a project called Africa at Home. This was a spin-off of the work that Ben and I did on LHC at home. It's a partnership that's been running for 2 years between CERN, the World Health Organization, the Swiss Tropical Institute, the University of Geneva, and 2 NGOs, IC Volunteers and Informaticiens Sans Frontières. The idea behind Africa at Home is that since volunteer computing and volunteer thinking are a poor man's grid, well then they ought to be very valuable resources for the developing world. Most African universities have good enough internet to run a server for a volunteer computing project. So the ultimate goal of Africa at Home is to enable African scientists using servers in African institutions to plug into a global network of volunteer computers and thinkers. And I emphasize global. The idea here is not them just getting power out of African computers. It is, and that's what our experience shows, the vast majority of the power is coming from computers in the north. The picture you see here was taken at an Africa at Home workshop that we ran in South Africa last summer, where 35 African scientists from 18 different countries learned hands-on how to set up and run a volunteer computing project. So one example of a volunteer thinking project that we're starting to work on is called Africa Map. This is being led by 2 researchers at universities in Ghana and the Central African Republic. And they're working with the UN satellite image team UNOSAT, which is actually based at CERN. The aim here is to get volunteer thinkers to make useful maps using recent satellite images. This will help UN agencies deal with disasters such as floods or earthquakes in regions where there are no maps or where the maps that exist are hopelessly out of date. At this point, I'd like to give the word to a volunteer. In this talk, I've referred to volunteers as the general public or ordinary citizens. This was not meant to be patronizing, it's just a shorthand. Of course, no one is general. No one is ordinary. And it doesn't matter what your title is or how many degrees you have, what matters is that you're passionate about the things you do. Last week, I got an email from just such a passionate volunteer. Peter Minton is a middle school teacher in San Diego. That's his avatar. He writes to me that in his spare time, on evenings and weekends, his passion is making maps. He has an impressive website full of maps he's made, and at the end of the email, he offers his help to the Africa Map project, stating, "I am very serious about my mapping craft and would welcome the opportunity to work towards a better map of Africa for everyone." That's the spirit of citizen cyber science. So what about the future of volunteer computing, volunteer thinking, and citizen cyber science? Well, I'm optimistic that there is a huge potential for this in other parts of the world. So optimistic, in fact, that I'm about to move to the Far East for a year and start up a new project called Asia at Home. The aim here is to encourage more Asian scientists to use volunteer computing and volunteer thinking. But I also think that Asia, as has been emphasized in many of the talks here at LIFT, would be a great place to launch a new trend, mobile volunteer computing. So if you're interested in that prospect, and you think you might have something to contribute, let's talk. Meanwhile, here in Geneva, we're planning to set up a Citizen Cyber Science Center, which will start as a United Nations, CERN, University of Geneva initiative and rapidly branch out, we hope, into a global partnership to stimulate new volunteer computing and volunteer thinking projects for humanitarian causes. Again, if you're interested to take part in that, get in touch. Finally, I would like to end with a wish to all of you young, ambitious, and delightful lifters. Yesterday was the beginning of a new year, the year of the rat. A rat year, I am told, is a good year to begin a new job, launch a product, or make a fresh start. Ventures begun now may not yield fast returns, so they say, but opportunities will come for people who are well prepared and resourceful. The astrological advice is that the best way to succeed in the year of the rat is to be patient, let things develop slowly, and make the most of every opening you can find. Now, of course, I'm a scientist, so I don't believe in any of that astrological bunk, right? But I've heard that even if you don't believe in it, it works. Okay? So with that thought, ladies and gentlemen, I wish you all an excellent year of the rat. Domo arigatou gozaimashita.